This is review C, numbers 11 through 20. On number 11, we're given a graph from 0 to 6, and it says that this is the graph of f prime, or the slope of f. We also know that f of 0 is equal to 1, and it says what is the minimum value of f on the interval. Okay, so for me to have a minimum, I know that the function has to go from negative to positive. Now, that occurs right here when x is 3. Okay, so we have a negative y to a positive y, and remember that this is on the slope, so that's decreasing to increasing, which means at x equals 3 we have a minimum. But that's not the minimum value. The minimum value is the y coordinate when x is 3, so I'm going to have to do a little bit more work here. I know one thing, that's the integral from 0 to 3 of f prime of x. Takes me back to the original function. If we use the first fundamental theorem, we could say that that's f of 3 minus f of 0, right? F of b minus f of a. So one thing that I can use here is f of 0 is equal to 1. So I can replace f of 0 with 1. I can also replace this integral with the area from the graph, since these are geometric shapes. Okay, so the area here would be a triangle, so 1/2 base times height, which would be 1/2. The base here is 3. The height is -2. And so that leaves me f of 3 minus, again, f of 0, which is 1. Okay, so if I want to find f of 3, all I have to do is simplify this and add 1. So 1/2 times 3 times -2, the 2's cancel, and I have -3. And then if I add the 1, that gives me -2. And that's your answer. Okay, on number 12, let f be the function given by f of x equals 4 to the x. You're going to divide it into 4 subintervals of equal length, and then find a right Riemann sum approximation. Okay, so we know that the area of each rectangle is going to be 1/2 times the height. Okay, if I take 0 to 2 and I divide it into 4 equal sections, each section is going to be of width 1/2. So that's going to be the width of each rectangle. Okay, now to find the height of the first rectangle, all I would need to do is plug in 1/2 to 4 to the x. Okay, so we'd have 4 to the 1/2. And now we're going to find, that's the area of the first rectangle. The area of the second rectangle would be, again, 1/2 for the width times, now this time we'd be at 1, so 4 to the 1, plus 1/2 times, okay, so we have 1/2, 1, now 1.5, so 3/2, plus 1/2 times 4 to the, so 1/2, 1, 3/2, and then 2. Okay, so again, because this is a right Riemann sum, we use the right side of the rectangle. If it was a left Riemann sum, we'd start with 0, and then we'd have 1/2, and then 1, and then 1.5, and we'd stop there, and we wouldn't use 2. Okay, so now we just need to simplify this. So we have 4 to the 1/2 is the square root of 4. That's 2 times 1/2 is 1. 4 to the 1 is 4 times 1/2 is 2. 4 to the 3/2, that's the square root of 4 cubed. So the square root of 4 is 2, cubed is 8, times 1/2 is 4. 4 squared is 16, times 1/2 is 8. Okay, so now we have 1 plus 2 plus 4 plus 8, so that's 3, 7, 15. And that's your right Riemann sum. Okay, so if you like to visualize it, you could have graphed it. Okay, so you know that a to the x, in this case 4 to the x, looks something like this. Okay, and we were going from 0 to 2. Using right Riemann sum. So if this is 1 and this is 2 and we want 4 subintervals, you've got 1/2 and 3/2 in between. You draw your rectangle up. Draw your rectangle up. So this is an over approximation. Okay, so you can see how the width is 1/2 for each one. 1/2, 1/2, 1/2, 1/2. The height is the curve at 1/2, the curve at 1, the curve at 3/2, the curve at 2. So you plug those values into the equation. Okay. Now we need to look at number 13, the derivative of this quotient. So we'll use the quotient rule. So it's going to be the bottom make sure you use parentheses, times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, now we just need to simplify a little bit. We've got 2x squared plus 4 minus 4x squared plus 2x over x squared plus 2 squared. Okay, so 2x squared minus 4x squared is negative 2x squared plus 2x plus 4. And that would be your final answer. Okay, on number 14, the velocity is given by v of t equals cosine 2t. If the particle is at x equals 3 when t is 0, that's your initial condition, what is the particle at t equals pi over 2? So again, if you have an initial amount here, you need to add it to the integral, because we're going from velocity back to position. So we have the integral from 0 to pi over 2. And you put your function here, cosine 2t dt. Okay, so let's let u equal 2t. So du is 2 dt. So 1/2 du is dt. Okay, and then we need to find u of pi over 2 and u of 0. Okay, so u of pi over 2, 2 times pi over 2 is pi. U of 0 would be 0. So we have 3 plus 1/2, the integral from 0 to pi, of cosine u du. Okay, the antiderivative of cosine is sine. So we have 3 plus 1/2 sine u from 0 to pi. Okay, so I'm going to have to go back this direction. 3 plus 1/2 sine pi. Sine pi is 0. And then c minus sine 0, which is also 0. And so we have 3 plus 1/2 times 0, which is just 0. So just 3 is our answer. Okay, again, 1/2 times 0 is 0, plus 3 is 3. And you're done. Okay, let's look at number 15. Okay, the function y equals g of x is differentiable and increasing for all real numbers. On what intervals is the function decreasing? Okay, so on this one, I would go ahead and find y prime because we're talking about increasing and decreasing. And you know that that always deals with the slope or the derivative. So the derivative here would be the derivative of the outside, so g prime, we leave the inside alone, times the derivative of the inside, so 3x squared minus 12x. And usually to find decreasing or increasing, we'd set the derivative equal to 0 and we would evaluate. So let's set this equal to 0 and we would find the critical values. Okay, well it tells me that g of x, or y equals g of x, is increasing for all real numbers. So that means that g prime of x is positive for all real numbers. So now we just need to deal with this factor. So let's take out the GCF, 3x. We'd have x minus 4 left. And so then we'd have x equals 0 and 4. And let's test it. So you plug it into y prime. Okay, so we've got 0 here, 4 here. If I plug in something less than 0, I'm going to get a positive. Something between 0 and 4, I'm going to get a negative. Something greater than 4, I'm going to get a positive. Okay, so we're looking for decreasing, so 0 to 4. Okay, because a negative times a positive would be a negative. Okay, number 16, we've got a limit as x approaches 2 from the left. I think the easiest way to look at this is just to make a table and see what's happening left of 2. So x is maybe negative 1, 0, and 1. The 3 whole numbers left of 2. And then y is this function. So if I plug in negative 1, the absolute value of negative 1 minus 2 is the absolute value of negative 3, which is 3. Negative 1 minus 2 is negative 3, and the quotient is negative 1. 0 minus 2 is negative 2. The absolute value is 2. 0 minus 2 is negative 2. The quotient is negative 1. 1 minus 2 is negative 1. The absolute value would be 1. Divided by negative 1 is negative 1. So the limit is negative 1. Okay, on 17, we have f of x equals a e to the ax. Find f prime. Okay, and a is a constant. So f prime is going to be a e to the ax times the derivative of ax, which is a. Okay, so we have a times a, which is a squared, e to the ax. Think about this as if you had a 2 there, 2e to the 2x. You'd keep this whole thing, and you'd bring it down, and then you'd multiply by the derivative here. That's all we did. Okay, number 18, you're supposed to find where the student made a mistake. That occurs in step 3. When you are raising e to this power, you have to raise it to the entire power. So c is part of the exponent, and what they did is they accidentally just left it out to the side and brought it down. So this c should be part of the exponent. So that's where they went wrong, step 3. Okay, so moving on to number 19. We have the graph of y. We want to know where it has a point of inflection. Remember, inflection points are the second derivative. So the first derivative would be 8x cubed plus 30x squared. The second derivative, 24x squared plus 60x. And we set that equal to 0 and set up our table to see where the sign changes. So the GCF here would be 12x. We have 2x plus 5 left, so x is going to be 0 and negative 5 over 2. So let's set up our table. Okay, less than negative 5 halves, so maybe negative 10. If I plug in negative 10, I'm going to get a negative times a negative, which is a positive. If I plug in maybe negative 1, I have a negative times a positive, which is a negative. If I plug in something greater than 0, so maybe 1 or 2, I would have a positive times a positive, which is a positive. So points of inflection would be where the sign changes. So from positive to negative, which is negative 5 halves. And from negative to positive, so 0. So we have 2 points of inflection. Make sure that you always test your points of inflection because you won't always get alternating signs, so be careful about that. Okay, on number 20, we have a limit as x approaches 2. This question is actually not going to be tested on your exam this year, but it will be tested starting in 2017. So this was on one of the exams in the past as a field question. You still want to get it if you can, okay? So what you're going to do in this case is use L'Hopital's rule, which says that you can differentiate the top and differentiate the bottom, and then apply the limit. Okay, so let's differentiate both. Okay, so the derivative of ln x plus 2 minus ln 5 would be 1 over x plus 2 minus 1 over 5. And then the derivative of x minus 3 is just 1. Okay, now let's plug in the 2. So we have 1 over 2 plus 2, which is 4, minus 1 over 5. Oh, wait just a second. I'm sorry, I made a mistake. The derivative of ln 5 is not 1 over 5. ln 5 is a constant, right? So this is actually 0. So get rid of this. Sorry about that. Remember, ln 5 is a number. If you put that in the calculator, you're going to get some decimal. And the derivative of any fraction, any number, any constant is 0. So don't make that mistake. That was a stupid mistake. Okay, so 1 over x plus 2 is 1 over 2 plus 2 is 1 over 4, and that's your solution. Again, I don't expect to see this on the 2016 exam, but it was on the 2014 or the 2013, so you never know, okay? But it shouldn't be, it's a field question.